Hello there. Welcome back to Dreamland Science. Tonight, we're going somewhere quite wonderful, not outward into the distant cosmos, but inward into you. Because every atom resting quietly in your body right now was once part of a star, a real star, one that burned for millions of years, lived its full and patient life, and then, gently, gave itself back to the universe. You don't need to remember any of this. You don't need to stay awake for all 100 of these facts. They are simply here to keep you company. Like distant starlight, arriving softly, without ever asking anything in return. If this channel has become part of your nighttime ritual, a like or subscribe helps other sleepy souls find their way here. 2. One quiet night at a time. So settle in. Let your body find its resting place. Let your thoughts begin to slow. And let us begin with the very first light the universe ever made. The universe began with almost nothing, 13.8 billion years ago. In the first moments after the Big Bang, the cosmos was unimaginably hot and dense. As it expanded and cooled, the very simplest atoms formed: hydrogen and a little helium. That was nearly everything. No carbon, no oxygen, no iron. Just the lightest, most delicate building blocks, drifting through an endless sea of energy. Think of a blank canvas, stretched quietly across infinity, waiting for its very first brushstroke. And somewhere in that vast, warm stillness, gravity began to whisper, pulling those simple atoms gently closer together, setting the stage for everything that would ever exist. The first stars were unlike anything we see in the sky today. They were colossal, some of them hundreds of times more massive than our Sun, born from the primordial hydrogen left behind by the Big Bang. These ancient giants formed roughly 200 million years after the universe began. Astronomers call them population 3 stars. They burned intensely hot and bright, living only a few million years before reaching their end. Imagine the first candles ever lit in a room that had known nothing but perfect, endless darkness. And when those great stars finally faded, they did not simply vanish. They left something behind, something that would quietly change the universe forever. Inside every star, atoms are gently pressed together. This process is called nuclear fusion. At the extraordinary temperatures and pressures found in a star's core, lighter atoms are pushed so close that they merge into heavier ones. In doing so, they release energy, the light and warmth that makes a star shine. It is a slow, patient process that can continue for billions of years. Picture a potter's hands, shaping clay on a wheel, turning something simple into something new, one quiet rotation at a time. Each time, 2 atoms merge inside a star. A tiny piece of the universe is transformed, and the elements that will one day build planets, oceans, and living things move one step closer to existing. The simplest recipe in the cosmos turns hydrogen into helium. Deep in the core of a star, 4 hydrogen nuclei are fused together to form one helium nucleus. A small amount of mass is converted into energy in the process, following the relationship that Einstein once described. This single reaction powers our Sun and nearly every star visible in the night sky. It is perhaps the gentlest alchemy in nature, taking the most basic ingredient the universe possesses, and slowly, patiently, creating something new from it. This reaction has been running in stars across the cosmos for over 13 billion years, and it all begins with hydrogen, the same element that still makes up 90% of the atoms in your body tonight. Our sun transforms 600 million tons of hydrogen every single second. That is an almost incomprehensible amount. Yet the sun does this so quietly, so steadily, that from where you lie tonight, it feels like nothing more than warmth on a summer afternoon. This process has been running continuously for about 4.6 billion years. And it will continue for roughly another 5 billion more. Perhaps you might notice your jaw beginning to soften just a little. The small muscles around your mouth releasing a tension you may not have realized you were carrying. The sun asks nothing of you in return for all those billions of years of quiet work. It simply shines, patient, steady, like a companion that has always been there. And always will be. Deep inside the most massive stars, helium is slowly transformed into carbon. When a star has converted much of its core hydrogen into helium, temperatures rise even further, to roughly 100 million degrees. At these extraordinary temperatures, 3 helium nuclei can fuse together in what physicists call the triple alpha process. The result is carbon, the 6th element on the periodic table, and one of the most versatile atoms in all of existence. It is like watching a quiet river reach a gentle waterfall. And in that moment of change, something entirely new is born. Carbon, the element that will one day become the backbone of every living thing on this planet, including you. Carbon is the foundation of all known life, and it was first made inside a dying star. Every protein in your body, every strand of your DNA, every cell membrane holding you together is built upon a framework of carbon atoms. And every one of those carbon atoms was forged in the core of a star that lived long before our sun existed. The carbon in your body tonight has traveled across billions of years and billions of miles to reach you. Think of it as a quiet inheritance, passed down through generations of stars, each one contributing a little more to the story. And tonight, that ancient inheritance rests inside you, steady, patient, still carrying the warmth of the star that made it. When carbon captures another helium nucleus, oxygen is born. Inside the hottest regions of massive stars, carbon and helium are pressed together to form oxygen, the element that makes up most of your body by weight. This reaction requires even higher temperatures than those that created carbon, occurring in the deepest, most intense layers of the largest stars. It is like a seed buried in warm soil, slowly unfurling into something essential and alive. Every breath you draw tonight pulls in oxygen atoms that were once at the heart of an ancient star, and every time you exhale, you gently return them to the world around you. Oxygen makes up 65% of your body by mass. More than any other element, oxygen defines the physical substance of who you are. It fills your lungs, flows through your blood, and makes up a large part of the water in every cell of your body. And all of it, every single oxygen atom, was created inside a star that lived and died long before the Earth existed. Imagine a vast, still lake on a quiet evening, and knowing that every drop of water in it once passed through the heart of something unimaginably powerful. You are, in a very real sense, an ocean of ancient oxygen, resting here tonight, breathing softly, quietly carrying the memory of stars. In 1954, a scientist named Fred Hoyle made a remarkable prediction. He proposed that carbon could only form inside stars if a very specific energy level existed, a resonance that would allow 3 helium nuclei to combine. Without this precise resonance, carbon would be extraordinarily rare, and life as we know it could not exist. His prediction was later confirmed through laboratory experiments, becoming one of the most celebrated insights in the history of astrophysics. Perhaps you might notice your shoulders settling a little deeper into whatever surface is supporting you right now, releasing just a fraction of the weight they have been carrying today. The existence of carbon, and therefore the existence of you, depends on a single, delicate property of physics, as if the universe had quietly arranged things. Just so, beyond carbon and oxygen, stars create a cascade of heavier elements. Neon forms when carbon captures another helium nucleus at even higher temperatures. Magnesium follows, then silicon. Each new element requires a hotter, denser environment to form, and each is built in a deeper layer of the star. As a massive star ages, it constructs these elements in sequence, one on top of another. It is like listening to a piece of music that grows slowly richer, each new note adding depth and warmth to a melody that has been building for millions of years. And with each new element, the star moves one step closer to the most extraordinary moment of its life. A massive star near the end of its life looks a little like an onion. If you could peer inside, you would find concentric layers, each one composed of a different element. Hydrogen on the outside, then helium, then carbon, neon, oxygen, silicon, and at the very center, a growing core of iron. Each layer represents a different chapter in the star's long, quiet story. Imagine peeling back the layers of something ancient and beautiful, and discovering that each one holds a different memory. The star has spent millions of years building these layers, one element at a time. And now, in its final days, it carries them all, like a traveler holding everything gathered along the way. At the very center of a massive star, iron is created, and that is where fusion comes to an end. Iron is element 26 on the periodic table, and it holds a unique position in physics. It is the most tightly bound nucleus, meaning that fusing iron into anything heavier would cost more energy than it releases. When a star's core begins to fill with iron, the process that has powered it for millions of years quietly reaches its limit. It is like watching a candle burn down to its very last glow. Not with sadness, but with a kind of reverence for all the light it has given. The star has forged everything it can, and now, something new is about to begin. Iron is the tipping point, the element that marks the boundary between creation and transformation. Every element lighter than iron can be made through fusion, a process that releases energy. But creating elements heavier than iron requires energy to be added. A star can forge hydrogen into helium, helium into carbon, carbon into oxygen, and so on up to iron. But no further. Not through fusion alone. Imagine reaching the top of a gentle hill and pausing there, looking out over a landscape you have never seen before. For the star, iron is that hilltop. Everything that comes next will require a different kind of event, something far more powerful. and far more generous than steady burning. When a massive star's core fills entirely with iron, it has given everything it can. The core, now roughly the mass of our sun but compressed to the size of a small city, can no longer generate the outward pressure needed to support the enormous weight above it. For a brief, quiet moment, the star is perfectly balanced, suspended between gravity and light, like a held breath. Perhaps you might notice the space between your eyebrows beginning to smooth, the small muscles of your forehead softening, releasing a tension that may have been resting there for hours. And then, in less than a single second, everything changes, not with harshness, but with a kind of cosmic generosity that is almost impossible to describe. In less than a second, the core collapses, and the star blooms outward. When the iron core can no longer hold, gravity takes over. The core collapses at nearly a quarter of the speed of light, reaching temperatures of over 100 billion degrees. A shock wave races outward through the star's layers, and in that single, luminous moment, the star scatters its elements: carbon, oxygen, silicon, iron, and dozens more, across light years of space. This is a supernova, not an ending, but a beginning, like a dandelion releasing its seeds into a warm afternoon breeze. In that single bloom, the star gives back everything it spent millions of years creating, offering it freely, without reservation. A supernova shines brighter than an entire galaxy for just a few weeks. For a brief window of time, one dying star can outshine the combined light of hundreds of billions of other stars. It is among the most luminous events in the known universe. And yet, despite that brilliance, it unfolds in the deep silence of space, where there is no sound at all. Think of it as a lantern, held up one final time in an endless hallway of darkness, its light reaching farther than anything that came before. And when the light gently fades, what remains is not emptiness. What remains is a gift, a cloud of newly forged elements, drifting slowly through space, carrying the quiet potential for worlds, oceans, and life. In that single bloom, elements heavier than iron are scattered across space. The shockwave of a supernova creates conditions extreme enough to forge entirely new elements, ones the star could not make through ordinary fusion. In a process called rapid neutron capture, neutrons collide with existing nuclei at extraordinary speeds, building heavier and heavier atoms in fractions of a second. It is like a sculptor working swiftly and surely in the final moments before the clay sets, creating forms that could not exist under quieter circumstances. Many of the elements that make you zinc, copper, selenium were born in moments like this, forged not in the steady patience of a star's life, but in the extraordinary grace of its farewell. Gold, silver, and platinum were created in the most dramatic moments the cosmos has ever known. These elements require conditions of extreme density and temperature to form, conditions found in supernova shock waves and in the collisions of stellar remnants. The gold that humanity has treasured for thousands of years, every flake of it, began as a flash of light in a distant corner of the galaxy, billions of years before anyone was here to notice. Imagine every golden thing you have ever seen: a ring, a sunlit reflection, a leaf in autumn, and knowing that each one began inside a star. And tonight, a trace of that ancient gold rests somewhere inside you, about 0.2 milligrams, almost nothing, but it is there, quiet, patient, yours. In 2017, scientists detected 2 neutron stars merging for the very first time. The event, known as GW 170817, was observed through both gravitational waves and light. A historic moment for astronomy. The collision lasted only seconds, but in that brief meeting, a vast amount of heavy elements were created and released into space. Researchers estimated that the gold produced in that single event was equal to several times the mass of the Earth. Perhaps you might notice your hands beginning to relax, your fingers uncurling slightly, letting go of whatever they have been holding on to today. 2 stellar remnants, each no wider than a city, drifting toward one another for millions of years. And in the moment of their meeting, creating gold, there is something almost tender about that. That single merger produced enough gold to equal several times the mass of our planet. This discovery confirmed a theory debated for decades, that many of the heaviest elements in nature are forged not in supernovae alone, but in the collisions of neutron stars. These events, now called kilonovae, scatter precious elements across vast distances, seeding the space between stars with the raw materials for future worlds. It is like watching 2 travelers who have wandered alone for ages finally meet. And in their embrace, something precious and new comes into being. Somewhere, billions of years from now, those elements may find their way into the body of a living being, resting quietly in the dark, unaware that part of them was forged in exactly this way. Iodine, a trace element your thyroid gland quietly depends on, was created in neutron star collisions. Your thyroid uses iodine to produce hormones that help regulate your metabolism, your temperature, and even the rhythm of your heart. Without it, these processes would falter. And yet, iodine is so rare that it could only have been forged in the most extreme conditions the universe has to offer. Think of it as a tiny letter, written in the language of colliding stars, carried across billions of years, and read by your body every single day without you ever knowing. You rarely think about your thyroid, and yet tonight, it is working patiently inside you, powered by an element born in one of the most powerful events in cosmic history. The periodic table is, in many ways, a recipe book, written by generations of dying stars. Hydrogen and helium were made in the Big Bang. Carbon, oxygen, and nitrogen were forged in the cores of massive stars. Iron was created at the moment a star reached its limit. Gold, platinum, and iodine were born in neutron star collisions. Every element has an origin story, and every origin story leads back to a star. It is like opening a cookbook and realizing that every recipe was contributed by a different hand, each from a different time, a different place, a different life, and the dish they all contributed to is you, lying here tonight, a recipe written quietly across 13.8 billion years. In 1957, 4 scientists published a paper that changed how we understand the universe. Margaret Burbidge, Jeffrey Burbidge, William Fowler, and Fred Hoyle often called B2FH, wrote what many consider one of the most significant papers in the history of astrophysics. They described in detail the processes by which stars forge elements, from hydrogen all the way to uranium. For the first time, humanity had a complete picture of where the matter in our world comes from. It is a quiet legacy. 4 people, 1 paper, and a truth that connects every atom in the universe to the stars that made it. That truth is as real tonight as it was when they first set it down. Nearly 70 years ago, they showed us that we are not separate from the cosmos. We are its ingredients. Everything around you, the walls of your room, the blanket resting on you, the air you breathe, the body carrying you through each day. All of it was made inside stars. There is no boundary between you and the universe. You are not standing apart from the cosmos. Looking in, you are part of it. You have always been. Perhaps you might notice your feet beginning to warm. Or perhaps they are already warm. Resting gently, having carried you through another full day. And as we leave the great forges of the cosmos behind, we follow the Stardust now, out into the quiet spaces between the stars, drifting slowly, patiently, beginning a journey that will last billions of years and will end, eventually, with you. When a star dies, its elements drift into the space between stars. The death of a star is not an ending. It is a scattering. The carbon, oxygen, silicon, and iron that were forged over millions of years are released into the vast emptiness surrounding them. This space, the interstellar medium, slowly fills with the remains of countless stellar lives. Atoms that once burned at millions of degrees now drift in near-perfect silence, at temperatures close to absolute zero. Imagine autumn leaves, carried gently by the wind, settling across a wide and quiet meadow. And in that quiet drifting, something remarkable begins. Because gravity, even at its most gentle, never truly stops working. Slowly, patiently, it begins to draw those scattered atoms back together again. The space between stars is not empty. It is filled with ancient stellar ash. What astronomers call the interstellar medium is a thin veil of gas and dust that stretches between the stars of every galaxy. Most of it is hydrogen, but threaded through it are heavier elements. Carbon, silicon, iron, released by generations of dying stars. Though incredibly sparse, this material contains the raw ingredients for everything that will ever exist. Perhaps you might notice a gentle warmth spreading across your chest, as if something deep inside you recognizes this ancient stillness. It is the universe's great storehouse, a quiet library of elements, waiting patiently to be gathered and used once more. Every atom drifting there has a story, and every story began inside a star. Over millions of years, gravity gently pulls this dust into vast clouds. In certain regions of the galaxy, the interstellar medium grows denser. Atoms drift closer together. Dust grains begin to accumulate. Over immense stretches of time, tens of millions of years. These regions grow into enormous structures called molecular clouds. Some of these clouds span hundreds of light years across and contain enough material to form thousands of stars. It is like watching fog gather in a quiet valley at dawn. So slowly that you would never notice it happening. yet so surely that by morning, the entire landscape has changed. And within these great clouds, hidden from the light of surrounding stars, the next generation of worlds is quietly taking shape. These molecular clouds are stellar nurseries, where new stars are born from old ones. Deep within the densest cores of molecular clouds, gravity slowly wins its gentle contest with pressure. Clumps of gas and dust begin to collapse inward, growing hotter and denser at their centers. When the temperature rises high enough, nuclear fusion ignites, and a new star is born, made entirely from the remains of stars that came before. Think of it as a quiet garden, where every flower that blooms is grown from the soil of flowers that came before it. There is no true beginning and no true end in the life of the cosmos, only a long, patient cycle of giving and receiving. Stars die, clouds form, stars are born again, and with each turn of the cycle, the universe grows a little richer. About 4.6 billion years ago, one such cloud began to collapse. In a quiet corner of the Milky Way, along what is now called the Orion Arm, a molecular cloud that had been gathering stardust for millions of years reached a tipping point. Something, perhaps a gentle ripple from a nearby event, caused part of the cloud to begin falling inward, slowly at first, then with increasing certainty. This was the moment our solar system began. Perhaps you might notice the muscles of your stomach softening just a little, releasing a tension you may not have been aware you were carrying. Everything you have ever known, every sunrise, every ocean, every quiet evening, traces its origin to this single, patient collapse of ancient stardust. 4.6 billion years ago, a nearby supernova may have gently nudged it, triggering our solar system's birth. Scientists have found evidence that a star exploded not far from our molecular cloud just before it began collapsing. Short-lived radioactive isotopes, particularly aluminum-26, have been discovered in ancient meteorites, suggesting that a supernova shockwave passed through the cloud and compressed it just enough to begin its collapse. A dying star, in its final act, may have given birth to our entire world. It is like a gentle hand placed on the shoulder of something that was already ready to move, offering just enough encouragement to begin. One star's farewell became another star's first breath, and from that quiet exchange, everything you know came to be. Evidence of that ancient supernova still exists in the chemistry of meteorites. Meteorites that fall to Earth today carry within them a chemical record of the solar system's earliest moments. By analyzing the isotopic signatures locked inside these ancient rocks, scientists can read the conditions present when our solar system was forming. The presence of aluminum-26 and iron-60, isotopes that decay quickly, confirms that a supernova occurred very close to our forming solar system. Imagine holding a small stone in your hand and knowing that it carries a message written by a dying star 4.6 billion years ago. These meteorites are among the oldest objects you could ever touch, older than the Earth itself, older than the Sun. Small, quiet messengers from the very beginning of home. As the cloud collapsed, it spun into a flat disk of gas and dust. Conservation of angular momentum, a fundamental law of physics, meant that as the cloud contracted, it began to spin faster. much like an ice skater drawing their arms inward. The collapsing material accelerated into a rotating disk. This protoplanetary disk stretched hundreds of millions of kilometers across, with the young sun forming at its center. It is like watching a slow waltz, where all the dancers gradually spiral inward, moving in perfect, quiet harmony. Within this spinning disk, tiny grains of stardust began to meet, touch, and hold on to one another. The first fragile steps toward building a world. At the center, our sun ignited, a second-generation star made from recycled stardust. When the temperature at the core of the collapsing cloud reached roughly 10 million degrees, hydrogen atoms began to fuse. Light poured outward for the first time. Our sun was born, not from fresh, primordial hydrogen, but from material that had already passed through at least one previous star. Every photon it has ever produced carries the legacy of a star that came before. Perhaps you might notice your neck beginning to release, the small muscles along either side softening, allowing your head to rest a little more heavily. Our sun is a second-generation star, a child of older, vanished suns, and everything it shines upon, including you, is made from the same inheritance. Tiny grains of dust began to collide and stick, slowly building larger and larger bodies. In the warm disk surrounding the young sun, microscopic particles of silicate, ice, and metal drifted together. When they met, weak forces, static attraction, surface chemistry, caused them to cling over thousands of years. These grains grew into pebbles. Pebbles grew into boulders. Boulders grew into bodies kilometers across. This process, called accretion, is how every rocky planet in our solar system began. Think of it as snowflakes gathering on a quiet winter night. Each one almost weightless, yet together, slowly building something solid and enduring. Patience. That is the word for how planets are made. An almost inconceivable patience, working grain by grain, across millions of years. Over millions of years, these pebbles became boulders, then planetesimals, then planets. The process of accretion accelerated as objects grew larger. Greater mass meant stronger gravity, which attracted more material. Planetesimals, bodies tens to hundreds of kilometers across, swept their orbits clean, colliding and merging in a slow-motion dance that lasted tens of millions of years. Eventually, a handful of dominant bodies emerged: Mercury, Venus, Earth, Mars, and the gas giants beyond. It is like watching a river form from 1,000 tiny streams, gradually joining, growing wider and deeper, until something magnificent flows where once there was only scattered rain. And among all those forming worlds, one, the third from the sun, would one day become home. Your home. Earth formed from the same stardust that made the sun. The material that became Earth was drawn from the same protoplanetary disk that formed our star. The iron in Earth's core, the silicon in its mantle, the oxygen in its crust. All of it came from the same cloud of recycled stellar material. Earth and Sun are siblings, born from the same ancient dust, shaped by the same patient gravity. Imagine two seeds, planted in the same soil, growing into very different things. One becoming light, the other becoming ground. And tonight, as you rest upon this planet, you are resting upon stardust that chose, through the quiet logic of gravity and chemistry, to become solid ground beneath you. Heavy iron sank to Earth's center, forming the core that generates our magnetic field. In Earth's earliest days, the planet was largely molten, denser elements, particularly iron and nickel, sank toward the center under their own weight, forming a metallic core roughly the size of Mars. The outer portion of this core remains liquid today, and its slow, churning motion generates Earth's magnetic field, an invisible shield that extends thousands of kilometers into space. Perhaps you might notice your wrists relaxing, your hands growing just a little heavier where they rest. That magnetic field still protects you tonight. It deflects charged particles from the sun, preserves the atmosphere that allows you to breathe, and shields the fragile chemistry of life. A quiet guardian, made of stellar iron, working patiently at the center of your world. That magnetic field still protects you tonight. A shield made of stellar iron. Without Earth's magnetic field, the solar wind would slowly strip away the atmosphere. Mars, which lost its global magnetic field billions of years ago, serves as a quiet reminder of what happens when that shield fades. Its atmosphere thinned, its oceans vanished. Earth, by contrast, has maintained its magnetic protection for over 3 billion years, thanks to the iron forged in ancient stars, now spinning slowly at the planet's core. It is like a blanket you cannot see, wrapped gently around the entire world, holding in warmth, holding out harm. You cannot feel it. You never think about it, but it is there, always. A gift from a star that lived long before the Earth existed, still keeping you safe tonight. Comets and asteroids delivered water to early Earth, water made from stellar hydrogen and oxygen. In the early solar system, icy bodies from the outer regions were scattered inward by the shifting orbits of the giant planets. When they struck the young Earth, they brought with them vast quantities of water. Hydrogen and oxygen atoms, bonded together, forged in separate stars and reunited in the frozen depths of space. Over hundreds of millions of years, these deliveries filled Earth's basins with oceans. Think of it as rain arriving from the stars themselves, falling not from clouds, but from comets across millions of quiet years. The water you drank today, the moisture in the air around you tonight, all of it was once ice, drifting through the darkness between worlds, waiting to find a home. The Murchison meteorite, which fell in Australia in 1969, contained amino acids. On September 28th of that year, a fireball streaked across the sky near the town of Murchison, Victoria. The fragments that were recovered contained over 70 different amino acids, organic molecules that serve as the building blocks of proteins. Many of these amino acids were types not commonly found on Earth, confirming that they had formed in space, not through terrestrial contamination. It is like receiving a letter from a very old friend you have never met, written in a language your body already knows how to read. These molecules had been drifting through space for billions of years before arriving on Earth, and within them was a quiet suggestion. Life's ingredients were already present in the cosmos. long before our planet existed. Amino acids are the building blocks of proteins, and they arrived from space. Proteins perform nearly every function in your body. They build your muscles, carry oxygen in your blood, defend you against illness, and transmit signals between your nerves. Every protein is assembled from a chain of amino acids, folded into precise three-dimensional shapes, and the discovery of amino acids in meteorites suggests that some of life's most fundamental components were delivered to Earth from the wider cosmos. Perhaps you might notice your lower back releasing just a little, the muscles along your spine softening as they let go of the day's quiet effort. The raw materials for your existence did not originate on this planet alone. They were carried here, gently, by rocks falling from the sky, arriving over millions of years, like guests at a gathering that had been planned since the stars were young. Phosphorus, essential for every strand of your DNA, was created in supernovae. Phosphorus is the element that forms the backbone of the DNA double helix. Without it, the genetic code that defines every living thing could not exist. Yet phosphorus is relatively rare in the cosmos. It can only be formed in the extreme conditions of a supernova explosion. Every atom of phosphorus in your body tonight was scattered into space by a dying star. It is like discovering that the ink used to write your most personal story was mixed in a furnace that burned brighter than a billion suns. Your genetic code, the quiet instructions that built you, cell by cell, from the very beginning, is written in an element that could only exist because a star chose, in its final moment, to give everything away. Scientists traced Earth's phosphorus back to a supernova remnant called Cassiopeia A. Researchers at Cardiff University examined the composition of Cassiopeia A, the expanding remains of a star that exploded roughly 340 years ago, as seen from Earth. They found that the phosphorus produced in such explosions is sufficient to account for the amounts found in our solar system. This provided a direct link between the phosphorus in your DNA and a specific type of stellar death. Imagine being able to trace a single thread in a tapestry all the way back to the hand that wove it. Billions of years ago, in a workshop of light and heat, the phosphorus in your cells has a return address, and that address is a supernova. About 3.8 billion years ago, the first living cell appeared on Earth, in warm, shallow waters, or perhaps near deep-sea hydrothermal vents. Simple molecules began to organize themselves into structures capable of self-replication. The precise mechanism remains one of science's great open questions. But what is certain is that every ingredient required was already present. Carbon from red giants, hydrogen from the Big Bang, nitrogen from massive stars, oxygen from stellar cores, and phosphorus from supernovae. It is like watching a quiet room full of scattered letters and seeing them slowly, mysteriously, arrange themselves into a sentence. That first cell was extraordinarily simple, yet it contained within it the potential for everything that would follow. Every forest, every ocean creature, every sleeping human being, including you. That cell was made entirely of stardust. Hydrogen, carbon, nitrogen, oxygen, phosphorus, the 6 elements most essential to life, often abbreviated as CHNOPS, were all present in that first cell. Hydrogen from the Big Bang, carbon and oxygen from stellar cores, nitrogen from the CNO cycle in massive stars, phosphorus and sulfur from supernovae. Life did not invent new materials. It simply arranged the gifts of dead stars into patterns complex enough to remember themselves. Think of it as the universe learning to fold paper, taking flat, simple sheets of stardust and creasing them into shapes that could move and grow, and eventually wonder where they came from. Every living thing on Earth today descends from that first arrangement, that first quiet act of cosmic origami. Cyanobacteria, tiny organisms, used stardust elements to create Earth's oxygen atmosphere. For over 1 billion years, these microscopic organisms harnessed sunlight to split water molecules, releasing oxygen as a byproduct. Slowly, over an almost incomprehensible span of time, they transformed Earth's atmosphere from one that was hostile to complex life into one that could support it. This event, called the Great Oxidation Event, roughly 2.4 billion years ago, was one of the most significant transformations in our planet's history. Perhaps you might notice your breathing has slowed just a little, each exhale arriving a fraction longer than the one before. Every breath of oxygen you draw tonight exists because of these ancient, patient organisms, tiny beings made of stardust, who spent 1 billion years quietly changing the world. Every breath you take tonight contains oxygen molecules first released by ancient microbes. The oxygen surrounding you in this moment has been part of Earth's atmosphere for over 2 billion years. It has been inhaled and exhaled by countless organisms. It has risen into thunderclouds and settled into still ponds. It has been carried by wind across oceans and through forests, and its ultimate origin lies in the hearts of massive stars, delivered to Earth by gravity and chemistry, and released into the air by the patient work of cyanobacteria. It is like breathing in a story that has been told and retold for billions of years. Each breath, a quiet page, carried softly into your lungs. You are part of that story now. With every breath, you take in the legacy of stars and microbes alike, and with every exhale, you gently return a small part of it to the world. The cycle of stellar birth and death has been running for over 13 billion years. Stars form, burn, die, and scatter their elements. Those elements gather, form new stars, and the process begins again. Each generation of stars produces heavier elements than the last, enriching the interstellar medium with increasing complexity. Our Sun is at least a second-generation star. Some of the atoms in your body may have passed through 3 or more stellar lives before reaching you. It is like a river that has been flowing since the beginning of time, and every drop of water in it has traveled a path unlike any other. This cycle has no known beginning and no foreseeable end. It simply continues, quiet, patient, endlessly generous. And every atom in your body has been part of that cycle, recycled through at least one star. Not a single atom in you is new. Every one has existed for billions of years. Every one has been somewhere else, inside a star, drifting through a nebula, resting in the core of an ancient planet, perhaps even part of another living being on a world long since gone. You are, tonight, a temporary gathering of ancient travelers. Perhaps you might notice that your body has grown a little heavier against the surface beneath you, as if it is remembering how to rest. the way stardust rests between journeys. And now, as we leave the long journey behind, we turn our attention inward to the quietest, most extraordinary destination of all, to the body that has been carrying you through this day, to the living museum of stars. That is you. 65% of your body mass is oxygen, forged in massive stars. More than any other element, oxygen defines the physical substance of who you are. It fills your lungs, flows through your blood, and makes up a large part of the water in every cell of your body. And all of it, every single oxygen atom, was created deep inside a star that lived and died long before the Earth existed. Stars larger than our Sun, burning at temperatures beyond imagination, fusing helium and carbon together until oxygen emerged. Perhaps you might notice the area around your heart softening just a little, as if something there recognizes how ancient and quiet this truth really is. You are, by weight, mostly oxygen, mostly something that was once at the center of a star, resting here tonight, breathing gently, carrying the memory of a fire that burned billions of years ago. 18.5% of you is carbon, cooked slowly inside red giants. Carbon is the second most abundant element in your body by mass, and the most versatile atom in all of chemistry. It forms the backbone of every protein, every strand of DNA, every sugar molecule, every fat, and every carbon atom in you was forged through the triple alpha process, a delicate chain of fusion reactions that takes place inside red giant stars, where 3 helium nuclei are pressed together at temperatures exceeding 100 million degrees. It is like discovering that the thread holding together the fabric of your entire being was spun inside a furnace of ancient light. Carbon is patient. It bonds easily, holds firmly, and builds structures of extraordinary complexity. Tonight, it is quietly holding you together, the same way it has held together every living thing that has ever existed on this planet. 9.5% of your body is hydrogen, the only element in you that came from the Big Bang. Every other element in your body was made inside a star, but hydrogen is different. It was created in the first few minutes after the universe began, when the cosmos was still unimaginably hot and dense. The hydrogen atoms in your body tonight are among the oldest things in existence, roughly 13.8 billion years old. They have never been inside a star. They have simply drifted through the universe, waiting until they found their way into you. Think of it as the universe's very first gift. Still here, still part of you. After all this time, you carry within you something that has existed since the very beginning, something that was present when there were no stars, no planets, no light, just hydrogen, waiting quietly in the dark. Hydrogen is the lightest element, yet it makes up 90% of your atoms. By mass, hydrogen accounts for less than 10% of your body, but by number, it dominates. 9 out of every 10 atoms in you are hydrogen. This is because hydrogen is extraordinarily light. Each atom weighs roughly 1/12 as much as a carbon atom, and 1/16 as much as an oxygen atom. So, while heavier elements make up most of your weight, hydrogen makes up most of your count. It is like a room full of whispers, each one barely audible on its own, yet together, they fill the entire space. You are, by atom count, almost entirely made of the simplest, oldest, lightest thing the universe ever created. And tonight, those ancient atoms are resting inside you, as quietly as they have rested for billions of years. 3.2% of you is nitrogen, created in stars larger than our sun. Nitrogen is a quiet, essential element. It forms part of every amino acid, every protein, every strand of DNA and RNA in your body. Without nitrogen, the chemistry of life could not function, and every nitrogen atom in you was forged through the CNO cycle, a chain of nuclear reactions that runs inside stars at least 1.5 times the mass of our sun. Perhaps you might notice the tips of your fingers beginning to soften. The smallest muscles releasing a tension so faint you may not have known it was there. Nitrogen asks for no attention. It simply does its work, quietly, invisibly, holding together the molecules that hold together you. And every atom of it traveled here from a star that once burned hotter and brighter than the one that warms your days. 1.5% of you is calcium, born in the explosive final moments of supernovae. Calcium is the element that gives your bones their strength and your teeth their hardness. It also plays a role in every heartbeat, every muscle contraction, every signal passed between your nerve cells. And it was created in the most violent moments the universe has ever known, the explosive death of massive stars, where temperatures soar to billions of degrees and elements are forged in fractions of a second. It is like discovering that the foundation of your house was laid by a thunderstorm, one that shook the sky, and then moved on, leaving behind something solid and enduring. The calcium in your body tonight was scattered across space by a dying star. It drifted for millions of years. It gathered into a cloud, collapsed into a planet, and eventually, through the quiet chemistry of life, became your bones. The calcium in your bones was scattered across space by a dying star. Every bone in your body, your spine, your ribs, the small bones of your hands and feet, contains calcium that was once at the heart of a stellar explosion. These atoms traveled across light years of space, drifted through molecular clouds, were gathered into the forming Earth, dissolved into ancient oceans, and were eventually absorbed by living organisms. Over billions of years, they found their way into the framework that supports you. Imagine a bridge built from materials gathered across an entire galaxy, each piece carried by gravity and time to exactly where it was meant to be. Your skeleton is a structure of extraordinary precision, and every atom of calcium within it has traveled a journey longer and stranger than any story ever told. Your skeleton is quite literally built from supernova debris. This is not a metaphor. It is not poetic exaggeration. The calcium and phosphorus that make up the mineral component of your bones were both created in supernova explosions. The collagen that gives your bones flexibility is built from carbon, nitrogen, and oxygen, all forged in stellar cores. Every structural element of your skeleton can be traced back to a star that no longer exists. Perhaps you might notice the muscles around your temples releasing, the quiet tension along the sides of your head beginning to dissolve, like mist in morning light. You are held upright tonight by supernova debris. You walk through your days supported by the remains of ancient explosions, and yet it feels like nothing more than your own quiet, familiar body. 1% of you is phosphorus. From supernovae, forming the backbone of your DNA. Phosphorus is the element that connects the nucleotides in your DNA into a continuous strand. Without it, the double helix, the molecule that carries the instructions for building and maintaining every cell in your body, could not exist. And phosphorus, like calcium, is created only in the extreme conditions of a supernova explosion. It is like learning that the binding of your most treasured book was stitched together by the light of a dying star. Your genetic code is, in the most literal sense, held together by stardust. The instructions that made you who you are, that shaped your face, your voice, your thoughts, are written on a scaffold built from the ashes of a star that gave its life so that yours could someday begin. Without phosphorus from dead stars, the double helix of life could not exist. The structure of DNA depends on a sugar-phosphate backbone, a long, spiraling chain of alternating sugar molecules and phosphate groups. This backbone provides the physical structure that holds the genetic code in place. Remove the phosphorus, and the helix unravels. The code is lost. Life, as we understand it, becomes impossible. Think of it as the quiet scaffolding behind a beautiful building. Invisible from the outside, yet without it, nothing would stand. Every living thing on Earth, every tree, every fish, every person, depends on phosphorus from dead stars to hold its genetic code together. It is one of the most extraordinary debts in all of nature, and it is paid silently in every cell of your body, every moment of every day. The potassium that helps your nerves fire was forged in oxygen-burning shells of giant stars. Potassium ions are essential for the transmission of electrical signals along your nerves. Every time you move a finger, blink an eye, or feel the weight of a blanket resting on you, potassium is at work, flowing in and out of your nerve cells, creating the tiny electrical currents that carry messages throughout your body. And this potassium was created in the oxygen-burning shells of massive stars, deep beneath their outer layers. It is like discovering that the electricity running through your home was first generated inside a star that died before the Earth was born. Every nerve signal in your body tonight is carried, in part, by atoms that once burned quietly inside a giant star. You feel the world through stardust. You always have. And then there is iron, perhaps the most poetic element in your body. Iron holds a special place in the story of stars and life. It is the element that marks the end of a star's ability to create through fusion. It is the element whose accumulation triggers a supernova. And it is the element that sits at the center of every hemoglobin molecule in your blood, carrying oxygen from your lungs to every cell in your body. Perhaps you might notice your ankles relaxing, the weight of the day slowly draining downward, leaving your legs feeling a little lighter, a little more at ease. Iron is where the story of creation meets the story of being alive. It is where the death of a star becomes the breath of a living being. And tonight, that ancient iron is quietly at work inside you. You carry about 4 grams of iron, roughly the weight of a small paperclip. It is not very much. 4 grams, spread across your entire body, dissolved into your blood, stored in your liver and spleen. Yet without those 4 grams, you could not survive. Iron is what allows your blood to carry oxygen. It is what gives your red blood cells their color. It is, in a very real sense, what keeps you alive. Think of it as a tiny key, so small you could lose it in the palm of your hand. Yet without it, no door in your body would open. 4 grams, the weight of a paperclip, the legacy of a star, the difference between breathing and silence. That iron sits at the center of every hemoglobin molecule in your blood. Hemoglobin is the protein that fills your red blood cells, roughly 270 million molecules per cell. Each hemoglobin molecule contains 4 iron atoms, arranged in 4 heme groups, each one capable of binding to a single oxygen molecule. When you breathe in, oxygen attaches to these iron atoms. When your blood reaches a cell that requires oxygen, the iron gently releases it. It is like a quiet courier, making the same journey 1,000 times a day, carrying a parcel of ancient air from your lungs to your fingertips. 4 iron atoms per molecule, 270 million molecules per cell, 25 trillion red blood cells in your body, and every single iron atom in every single one of them was once at the heart of a star. Each hemoglobin molecule holds 4 iron atoms, ancient stellar cores carrying oxygen through your veins. These iron atoms are not merely functional, they are historical. Each one was forged in the final stages of a massive star's life, at temperatures of billions of degrees, in the fraction of a second before the star could no longer sustain itself. They were scattered into space by a supernova, drifted through the interstellar medium for millions of years, were gathered into the forming Earth, and eventually, through the quiet chemistry of biology, found their way into your blood. Perhaps you might notice the palms of your hands growing warmer, as if they are being gently held by something very old and very kind. Right now, as your heart beats softly, those ancient iron atoms are moving through you, carrying oxygen, sustaining life, doing exactly what iron has always done, holding things together, quietly, at the very center. The iron in your blood tonight was once at the heart of a star that died billions of years ago. That star may have been many times the mass of our sun. It may have burned for 10 million years, fusing hydrogen into helium, helium into carbon, carbon into oxygen, and so on, until iron accumulated at its core and fusion could proceed no further. In the moment of its collapse, the iron was scattered outward, joining a cloud of elements that would eventually become our solar system. It is like inheriting a watch from a grandparent you never met, one that still keeps perfect time, billions of years after it was made. That iron is still working tonight, still carrying oxygen, still keeping you alive. A quiet inheritance from a star you will never know, doing its work as faithfully now as it did at the center of a burning sun. When that star could no longer sustain fusion, its iron core collapsed, and the star was reborn as a nebula. The collapse happened in less than a second. The core, suddenly unable to support the weight above it, fell inward at 1/4 of the speed of light. The resulting shockwave blasted the star's outer layers into space, creating a vast, glowing cloud of gas and dust, a supernova remnant, or nebula. These remnants are among the most beautiful structures in the universe, and they contain all the elements the star spent its life creating. Think of it as a final exhale. one so powerful that it filled the sky with color, and so generous that it seeded the galaxy with everything it had ever made. And from that nebula, over millions of years, new stars and new worlds would form, including, eventually, the one you are resting upon tonight. Your blood is, in a very real sense, carrying the legacy of that star. Every time your heart beats, it pumps roughly 70 milliliters of blood through your body. That blood carries hemoglobin, and that hemoglobin carries iron, and that iron was forged in a star that no longer exists. With each beat, a small river of ancient stardust flows through you, nourishing your cells, sustaining your tissues, keeping the quiet machinery of your body running. It is like a river that remembers its source. Even after flowing for billions of years, it still carries something from the mountain where it began. Your heartbeat is the rhythm of that river, steady, patient, ancient, and tonight it continues, as it has continued for every moment of your life. Carrying the memory of a star, you also carry traces of gold, about 0.2 milligrams, from neutron star collisions. It is an almost immeasurably small amount, less than a speck, yet it is there, distributed throughout your body, a faint echo of one of the most violent events in the known universe. The gold in you was created when two neutron stars spiraled toward one another and collided, releasing a burst of energy and forging heavy elements in fractions of a second. Imagine carrying a single grain of sand from the most distant shore on Earth. So small you would never feel it, yet so precious that nothing else in the universe could have created it. You carry gold tonight, not enough to see, not enough to weigh, but enough to remind you that the most extraordinary events in cosmic history have left their mark on you. Iodine in your thyroid, zinc in your immune system, selenium protecting your cells, all from dying stars. Your thyroid gland uses iodine to produce hormones that regulate your metabolism. Your immune system depends on zinc to function properly. Selenium serves as an antioxidant, protecting your cells from damage. These are trace elements, present in tiny amounts, yet absolutely essential for your health. And every atom of each one was created either in the slow neutron capture process inside red giant stars, or in the rapid neutron capture process during supernovae and neutron star mergers. Perhaps you might notice your eyelids growing just a little heavier, as if they are being gently weighted by something ancient and kind, inviting you to rest. Your body is a collaboration of elements from across the galaxy, each one created in a different star, at a different time, through a different process. And all of them, tonight, are working together inside you. Neil deGrasse Tyson once said that we are not figuratively, but literally, stardust. The astrophysicist has spoken often about the connection between human beings and the cosmos. In his words, the atoms in your left hand may have come from a different star than the atoms in your right hand. You are a collection of stellar debris, gathered together by gravity and biology, arranged into a pattern complex enough to think, to feel, to wonder, and that pattern is what you call yourself. It is not poetry. It is chemistry. It is physics. It is the most basic truth about who you are. You are not looking up at the stars from some distant, disconnected place. You are made of them. You are part of them. And tonight, They are quietly, literally, part of you. Your body contains roughly 7 octillion atoms, each one with a cosmic history. 7 followed by 27 zeros. That is approximately how many atoms are gathered together to form your body at this very moment. And each one of those atoms has existed for billions of years. Each has been somewhere else, inside a star, drifting through a nebula, dissolved in an ancient ocean, perhaps part of a creature that lived and died long before you were born. Think of it as a library with 7 octillion books, each one written in a different time, a different place, by a different hand, and all of them, somehow, telling the same story. You are not a single thing. You are a gathering, a quiet assembly of ancient particles, held together briefly by the gentle forces of chemistry and life. And your body replaces most of its atoms every few years. The atoms in your body are not permanent residents. They are visitors. Your stomach lining replaces itself every few days. Your skin renews roughly every 2 to 3 weeks. Your red blood cells live for about 4 months. Your skeleton is fully rebuilt over the course of roughly 10 years. The atoms that make up your body today are, in large part, different from the ones that made you up a decade ago. It is like a sandcastle that rebuilds itself constantly. Each grain replaced, one at a time, yet the shape remains. You are not the same collection of atoms you were as a child, and yet you are still you. The pattern persists. The story continues. And every new atom that arrives is still stardust. But every replacement atom is still stardust, borrowed from the earth, which borrowed it from a star. When your body takes in food, water, and air, it absorbs atoms from the world around you. Those atoms were in the soil, the rain, the atmosphere, and before that, they were part of the Earth, which formed from a cloud of stellar debris 4.6 billion years ago. You are constantly exchanging atoms with the planet, and the planet is constantly recycling atoms it received from the cosmos. Imagine a traveler who changes clothes at every inn along the road. But every outfit is sewn from the same ancient cloth. You are always being renewed. And you are always being renewed with stardust. The source never changes, only the arrangement. You are not a permanent thing. You are a pattern, held together briefly, made of ancient light. This is, perhaps, the most gentle truth of all. You are not your atoms. You are what your atoms are doing. You are a process, a pattern, a fleeting arrangement of matter that has been circulating through the cosmos for billions of years. The stardust that is you tonight will one day be something else. A tree, a stone, a wisp of cloud, perhaps part of another living being on a world not yet formed. Perhaps you might notice your whole body settling a little deeper, as if it is giving itself permission to simply be here, without holding on to anything at all. You are ancient. You are temporary. You are beautiful. And the stardust in you has been patient for a very long time. It can wait a little longer, while you rest. And now, as we leave the quiet museum of your body behind, we lift our gaze once more, outward, upward, to the stars that made you, to the cosmos that holds you, and to the deep, abiding peace of knowing that you belong. In 1968, astronaut William Anders took a photograph called Earthrise. During the Apollo 8 mission, the first crewed flight to orbit the Moon, Anders looked out the window and saw the Earth rising above the lunar horizon. A small, fragile, blue and white sphere, suspended in the absolute darkness of space. He raised his camera and captured an image that would quietly change how humanity saw itself, not as citizens of nations, but as passengers on a single, delicate world. It is like seeing your own home from a hilltop for the first time and realizing how small it is and how much you love it. That photograph became one of the most widely seen images in human history, and it began with a simple act of looking, of turning away from the Moon and gazing back at the place we all share. Seeing Earth from space changed something deep inside him, and many astronauts since. Anders later said that the crew had traveled all that way to explore the Moon, but what they truly discovered was the Earth. Many astronauts have reported similar experiences. A sudden, overwhelming sense of the planet's beauty and fragility. Some have described tears, others, silence. All have spoken of a shift in perspective so profound that it altered the way they understood their place in the world. Perhaps you might notice your whole body softening just a little, as if, for a moment, the boundaries between you and the space around you have grown quieter. You do not need a spacecraft to feel this. Sometimes, all it takes is a quiet night, a clear sky, and the willingness to look up. This experience is called the overview effect, a shift in how you see everything. The overview effect is a cognitive and emotional shift reported by astronauts who have seen the Earth from orbit or from the surface of the Moon. It is characterized by a sudden, deep awareness of the planet's unity, the thinness of its atmosphere, and the absence of visible borders. Many who have experienced it describe a feeling of interconnectedness, a sense that all life on Earth is part of a single, fragile system. It is like stepping back from a painting you have been standing too close to, and finally seeing the whole picture for the first time. The overview effect is not something that happens to your mind alone. It happens to your sense of self. It gently loosens the grip of ego and replaces it with something wider, quieter, and far more peaceful. Frank White gave it that name in 1987. White, a writer and researcher, interviewed numerous astronauts about their experiences in space and identified a common thread, a profound perceptual shift triggered by seeing the Earth from a great distance. He published his findings in a book called The Overview Effect, coining the term that would come to define this uniquely human experience. His work helped bring scientific and philosophical attention to what astronauts had been quietly describing for decades. Think of it as giving a name to something that had always existed. The way naming a constellation does not create the stars, but helps you see the pattern they already formed. Since then, the overview effect has become one of the most studied phenomena in the psychology of space exploration, and one of the most relevant to understanding peace, perspective, and belonging. Edgar Mitchell, who walked on the Moon, described a sudden sense of universal connectedness. Mitchell was the lunar module pilot on Apollo 14 and the sixth person to walk on the surface of the Moon. On the return journey to Earth, he looked out the window and experienced what he later called a profound sense of interconnectedness, a feeling that every atom in the universe was somehow linked, that the separateness he had always assumed was an illusion. He spent the rest of his life exploring that feeling. Perhaps you might notice your eyelids growing heavier, as if they have been waiting for a quiet moment to rest. And this is that moment. Mitchell walked on the moon, and what he brought back was not a rock, or a flag, or a photograph. What he brought back was a feeling that everything is connected, that nothing is truly separate, that we all belong to the same quiet, ancient story. Ron Garan called it the orbital perspective, seeing Earth without any borders at all. Garan, a NASA astronaut who spent 178 days aboard the International Space Station, described looking down at the Earth and being unable to see any of the political boundaries that define nations. From orbit, the planet appeared as a single, seamless system, atmosphere flowing freely, weather patterns crossing continents, oceans connecting everything. He called this the orbital perspective and advocated for using it as a framework for solving global challenges. It is like removing the lines from a map and seeing the land as it truly is, one continuous, breathing place. From space, there are no strangers, only neighbors, all living on the same small, bright world, all made of the same ancient stardust. You do not have to go to space to feel this. Sometimes a quiet night under the stars is enough. Not everyone will orbit the Earth or walk on the moon, but the essence of the overview effect, that deep, quiet sense of belonging to something larger, is available to anyone willing to look up on a clear night. Researchers have found that simply gazing at the night sky can produce feelings of awe, wonder, and a gentle dissolution of self-focused thinking. Think of it as a door that is always open, waiting patiently for you to step through whenever you are ready. Tonight, even from where you are lying, the stars are above you, and if you were to look up at them, they would look back at you with the same quiet light they have offered every human being who has ever lived. When you look at the stars tonight, you are looking back in time. Light travels at roughly 300,000 kilometers per second, the fastest speed anything in the universe can achieve. Yet the distances between stars are so vast that even at this speed, light takes years, decades, centuries, or even millennia to reach you. When you see a star, you are not seeing it as it is now. You are seeing it as it was when its light began its journey toward you. It is like reading a letter that was mailed a long, long time ago, and knowing that by the time it reaches you, the hand that wrote it may already be gone. The night sky is a museum of the past. Every star you see is a window into a different moment in cosmic history, and the light entering your eyes tonight has been traveling patiently just to reach you. The light from the nearest star, Proxima Centauri, left 4 years ago. Proxima Centauri is the closest star to our Sun, located roughly 4.24 light-years away. The light you would see from it tonight actually left that star more than 4 years ago. It has been traveling through the void of space ever since, crossing trillions of kilometers of emptiness, to arrive at your eyes in this exact moment. Perhaps you might notice your breath deepening just slightly, each inhale arriving a little more slowly, a little more gently, as if your lungs are learning the rhythm of something very far away and very old. 4 years of silent travel, trillions of kilometers of absolute darkness, and at the end of it all, your eyes, waiting, without knowing they were waiting for a message from the nearest neighbor in the sky. Some of the stars you see may no longer exist. Their light is still traveling. Some of the stars visible in the night sky are hundreds or thousands of light years away. A star 1,000 light years distant may have died centuries ago, yet its light continues to travel, crossing the galaxy at 300,000 kilometers per second, still carrying the image of a star that no longer shines. You see a memory, not a presence. It is like hearing a song that someone sang long ago. The singer is gone, but the melody still fills the room. The night sky is full of these gentle ghosts, stars whose light outlived them. And in that, there is something quietly comforting, because it means that even after something ends, its light can continue to reach others for a very, very long time. The observable universe stretches 93 billion light-years across. This is the portion of the universe from which light has had time to reach us since the Big Bang. Beyond this boundary, there may be more, perhaps infinitely more, but its light has not yet arrived. Within this observable sphere, there are an estimated 2 trillion galaxies, each containing billions of stars, each star potentially surrounded by planets. Think of it as standing in a room so large that you cannot see the walls, and knowing that the room may extend even further than you can imagine. You are inside this vast space tonight, a small, warm, conscious being, resting quietly on a planet orbiting one star among hundreds of billions. And yet, here you are, aware, present, gently breathing. It contains roughly 2 trillion galaxies, each with billions of stars. 2 trillion. That is 2 million galaxies, each one a vast island of stars, gas, dust, and dark matter. Our own Milky Way is just one among them, a medium-sized spiral galaxy, roughly 100,000 light-years across. And yet, within our galaxy alone, there are between 100 and 400 billion stars. It is like counting grains of sand on a beach, and then learning that there are 2 trillion beaches. The numbers are almost meaningless in their enormity. They are not meant to be grasped. They are meant to be felt, and what they invite you to feel, perhaps, is a kind of gentle surrender, a willingness to let go of the need to understand everything, and simply rest in the presence of something unimaginably vast. Our Milky Way alone holds between 100 and 400 billion stars. Each of those stars is a furnace of nuclear fusion, converting lighter elements into heavier ones, shining light across the galaxy, and eventually, when its time comes, scattering its elements back into space. Some of those stars have planets. Some of those planets may have water. Some may even have life. And all of them, without exception, are made of the same stardust that made you. Perhaps you might notice your spine settling just a little deeper, each vertebra releasing, one by one, like stones gently placed on soft ground. You share your origins with every star in the Milky Way. You are made of the same material, shaped by the same forces, born from the same ancient process. In the language of the cosmos, you are family. And yet, every element that makes you was made in stars just like these. The oxygen in your lungs, the carbon in your cells, the iron in your blood, the calcium in your bones. All of it was forged inside stars scattered across the Milky Way. You are not observing the galaxy from the outside. You are part of it. You are one of its creations, assembled from its materials, breathing its air, resting on one of its planets, under the light of one of its stars. It is like realizing that the painting you have been admiring was made partly from your own bones. You belong to the Milky Way the way a wave belongs to the ocean. Not separate, not apart, simply a momentary shape, rising gently from something much larger, and one day returning to it. Researcher Daka Keltner at Berkeley found that awe, the feeling of vastness, reduces inflammation. Keltner and his colleagues at the University of California studied the physiological effects of awe. That quiet, expansive feeling you get when you encounter something much larger than yourself. They found that experiences of awe were associated with lower levels of pro-inflammatory cytokines, molecules linked to chronic stress and disease. In other words, feeling small in the presence of something vast may actually help your body heal. Think of it as medicine that arrives not through a needle or a pill, but through a window. On a clear night, when you happen to look up, the stars are not just beautiful. They may, in a very real sense, be good for you. And tonight, simply lying here and letting yourself feel the vastness of the cosmos may be one of the kindest things you can do for your body. It also reduces the voice of the inner critic, the part of you that worries and replans. Keltner's research further showed that awe experiences diminish the activity of the default mode network, the part of the brain most associated with self-referential thinking, rumination, and worry. When you feel awe, the inner narrator grows quieter. The constant loop of planning, judging, and evaluating softens. What remains is a wider, more peaceful awareness, one in which you are present, but not anxious. Perhaps you might notice that the space between your thoughts has grown just a little wider, as if the quiet is expanding gently, making room for rest. Awe does not silence your mind. It simply invites it to step back, to take a seat, to watch the vastness, instead of trying to control it. Psychologists call this the small self effect. Feeling small actually brings peace. A 2015 study published in the Journal of Personality and Social Psychology found that experiences of awe produce a measurable reduction in the sense of self-importance, what researchers call the small self. Participants who experienced awe reported feeling less focused on their own concerns, more connected to others, and more generous. Paradoxically, feeling small made them feel better. It is like setting down a heavy bag you have been carrying all day, and realizing that you were allowed to set it down at any time. You do not become less by feeling small. You become lighter. And tonight, if the vastness of the cosmos makes you feel like a tiny, flickering point of warmth in an infinite darkness, that is not a loss. That is a gift. Oliver Burkeman calls it cosmic insignificance therapy, the relief of not mattering so much. In his book, 4,000 Weeks, Burkeman describes the strange comfort that comes from accepting your smallness in the face of cosmic time. He argues that the pressure many people feel to be productive, to be exceptional, to leave a lasting mark, dissolves when you truly absorb the scale of the universe. You are here for a brief moment, The universe has been here for nearly 14 billion years. And that is not a tragedy. It is a release. Think of it as being a single note in a symphony that stretches across all of time. And finding peace in knowing that your note, however brief, is part of the music. You do not have to carry the weight of permanence. You only have to be here, quietly, gently, for as long as you are here. Carl Sagan once looked at a photograph of Earth, a tiny, pale blue dot, and said something unforgettable. In 1990, the Voyager 1 spacecraft, at a distance of roughly 6 billion kilometers from Earth, turned its camera around and took a photograph of our planet. Earth appeared as a single, pale blue pixel, barely visible against the deep black of space. Sagan reflected on that image in words that have since become some of the most quoted in the history of science. It is like looking at a single grain of sand on a vast, dark beach, and knowing that everything you have ever loved is resting on that grain. He said, "Look again at that dot. That is here. That is home. That is us. Everyone you have ever loved. Every human being who ever existed lived on that dot. Every king and every beggar, every teacher and every student, every act of kindness and every moment of sorrow, every sunrise anyone has ever seen, every lullaby anyone has ever sung, every breath anyone has ever drawn. All of it happened on that tiny, pale blue point of light, suspended in a sunbeam, in the vast and silent darkness of space. Perhaps you might notice your toes beginning to soften, the smallest muscles in your feet releasing, as if they, too, are ready to let go of the ground they have been standing on all day. Everyone you have ever known is on that dot, and so are you, resting here, part of the same small, bright, ancient story. Every person you pass on the street is made of the same stardust as you. The strangers on the bus, the person at the counter, the child running in the park, every one of them is built from the same cosmic ingredients, the same hydrogen from the Big Bang, the same carbon from red giants, the same iron from supernovae, the same calcium from stellar explosions. There is no elemental difference between you and anyone else. At the atomic level, you are identical. It is like discovering that everyone at a gathering is wearing different clothes. But underneath, they are all made of the same light. There are no strangers in the cosmos, only stardust, briefly gathered into different shapes, each one looking out at the universe from a slightly different angle. The calcium in your bones might once have been in a mountain, or a dinosaur, or a distant moon. Atoms are recycled endlessly. The calcium in your femur may have once been part of a limestone cliff, formed from the shells of ancient sea creatures. Before that, it may have been dissolved in a primordial ocean. Before that, it drifted through a molecular cloud. Before that, it was at the heart of a supernova. And in the future, it may become part of a tree, or a riverbed, or a creature that has not yet evolved. Think of it as a traveler with an infinite itinerary, who happens, tonight, to be resting inside you. You are a waypoint in the journey of every atom you contain, a brief, warm stop on a voyage that began billions of years ago, and will continue long after you are gone. In about 5 billion years, our sun will expand, shed its outer layers, and return its elements to space. When the sun exhausts its hydrogen fuel, it will swell into a red giant, engulfing the inner planets. Eventually, it will shed its outer layers into space, forming a planetary nebula, a beautiful, glowing shell of gas enriched with the elements it spent billions of years creating. The core will remain as a white dwarf, a dense, fading ember, slowly cooling over trillions of years. It is like a tree at the end of a long and generous life, dropping its leaves one final time, each leaf carrying a seed for something new. The sun has been shining for 4.6 billion years. It will shine for roughly 5 billion more, and when it is finished, it will give back everything it has, the same way the stars before it did. Those elements will drift into a new cloud, collapse into a new star, and perhaps form new worlds. The carbon, oxygen, and nitrogen released by our dying sun will join the interstellar medium, the same great reservoir of elements that gave birth to our solar system. Over millions of years, gravity will gather them into a new molecular cloud. That cloud will collapse. A new star will ignite. New planets will form. And perhaps, on one of those planets, in some distant future, something will stir, something that breathes, something that wonders. Perhaps you might notice that you have grown very still, your body resting deeply, your thoughts moving slowly, like clouds drifting across a wide and quiet sky. The cycle will continue. It always has. And the atoms that are you tonight will be part of whatever comes next. The cycle will continue, and the stardust that is you tonight will become part of something new. One day, the atoms in your body will return to the earth. They will dissolve into soil, rise into air, flow into rivers. They will become part of plants, of animals, of rain, and in time, perhaps a very long time, some of them will find their way back into space, back into a cloud, back into a star, and the story will begin again. Not the same story, but the same stardust, carrying forward everything it has ever been. It is like a song that never truly ends. Each verse different, but the melody always recognizable, always gentle, always yours. And now, as the 100th fact settles quietly into the space around you, there is nothing left to learn tonight, nothing left to hold, only the quiet truth that you have always been part of this, and you always will be. You are not just living in the universe. You are the universe, briefly gathered into a shape that can wonder about itself, a shape that can lie here in the quiet darkness and feel something close to peace, a shape that can hear 100 facts about the stars and recognize, somewhere deep inside, that they were never really about the stars at all. They were about you. You are made of hydrogen that has existed since the very first moment, carbon that was cooked slowly inside a red giant, oxygen forged in the heart of a star 10 times the mass of the sun, calcium scattered by an explosion that outshone an entire galaxy, iron that marked the end of one star's life and the beginning of yours. You do not need to hold on to any of this. These facts will still be true tomorrow. The stardust in your bones is not going anywhere. It has been patient for 13.8 billion years. It can wait a little longer while you rest. Perhaps you might notice that your shoulders have softened, your jaw has loosened, your breath has found its own quiet rhythm, as if your body already knows it belongs to something much larger than tonight. So rest now, sleepy soul. You are safe. You are ancient. You are made of the same light that fills the sky above you. And wherever your dreams carry you tonight, remember, you are already home. You have always been home. Good night. And may your dreams carry you gently back to the stars.